Okay, so what did you get? Here's the number I got. So when you actually solve the same equation, but this time for Q equals to 25 instead of 50, these are the new numbers of labor you get. When capital is 20, labor is 31. When capital is 50, labor is 13. When capital is 100, labor is 6. When capital is 125, labor is 5. And if you take these new numbers and plot them in the same diagram, what you get is a curve like this red curve right here, which has the same shape as the original isoquant when Q was equal to 50, but is closer to the origin. And if you had done this for Q equals 75, you would have gotten the same curve, but this time to the right of the origin. So basically, this is like the utility curve, right? When the output is larger, the isoquant is going to shift to the right. When output is smaller, the isoquant would shift to the left. And along the isoquant is the same output, but with different combinations of the inputs. All right, now let's get a little more detail about this isoquant stuff. So let's go back and put the same numbers in here. So let's get rid of this here, so I have more space to work. And get rid of that one, and get rid of that one. But let's get rid of that. Well, small one there. And the real numbers we have for output was when output was equal to 50, and this was 125, this was 50, this was 25, and this was 20. Now let's focus a little bit on the slope of the isoquant, which is going to have a really important implication for production. So you know that along the isoquant, what I just told you is that the change in output is going to be the same. So that means that when let's say you're moving from from A to B, right? So let's say you're moving from this point to this point. So you're gonna gain some capital and you're gonna lose some labor, right? So your gaining in capital is gonna be, it's gonna be, oops, what is this? It's gonna be the increase in capital times the amount of output that you get every time you increase your capital by 1. And that we know we call the marginal productivity, in this case of capital. And that's going to be negative since we are actually losing capital if we're moving from A to B. But we are actually gaining labor, so we have to add that to our output. We're gaining output from the additional labor. We're losing output because we are losing some capital, but we're going to replace that output with additional labor, and the increase in output from labor is going to be equal to, whatever more labor we're going to add times how much output we get for every additional units of labor, which is the marginal productivity of labor. So in essence, what you have is that the change in output is going to be equal to the marginal productivity of capital times the change in capital, and the marginal productivity of labor times the change in labor. But you already know that the change in output along an isoquant is 0. So essentially, what you have here is that along the isoquant, these two terms are essentially the same, right? Because if the change in output is 0 and I bring one of this term to the other side, what I have is this. Change in capital times marginal productivity of capital equals change in labor times marginal productivity of labor if the change in capital is 0. And since what I want to do here is to focus on the slope of this curve, which is change in capital over change in labor, let's solve for that. So first of all, we're going to divide this by the marginal productivity of capital, so we're going to end up with change in capital equals change in labor times the marginal productivity of labor divided by the marginal productivity of capital. And now, since what we want is the slope, let's divide again this whole thing by the change in labor, and we're going to end up with the change in capital over the change in labor equals the marginal productivity of labor over the marginal productivity of capital. And this is a really interesting and useful result. So in here, what do we have? In here we have the slope of the isoquant, change in K over change in L, change on the y-axis, change over change in the horizontal axis. And that is telling me that the slope of the isoquant is going to be the same as the ratio of the marginal productivity of labor to capital. Does that make sense? Well, think about it. What we just said before is that when this slope is actually very high or large in absolute terms, when you have very little labor, every additional unit of labor replaces a lot of capital. So that means that when you have very little labor, this number, the marginal productivity of labor, will be high, and the marginal productivity of capital is going to be low. So the slope, which is the ratio of the marginal productivity, is going to be small. So that makes a lot of sense. Now, when this ratio, the change in capital over change in labor, is actually very small in absolute terms, we look up here, that's when you will be, let's say, somewhere around, let's do this in red, that will be when you're, let's say, around here. And at that point, how productive is labor? Well, according to this value has to be small. So the marginal productivity of labor had to be actually pretty low, and the marginal productivity of capital have to be high. If not, this ratio here is not going to be this equal to this slope. And that makes a lot of sense. That's exactly how it is, because we know that when you have a lot of labor, when you're at A and you want to move to B, you're going to need a lot more labor to actually replace the capital than when you actually have very little labor. So that's because the marginal productivity of labor is actually very low when you actually have a lot of labor. So you need a lot more units of labor to replace for capital. When you're moving from A to B, let's say from B to A, you're going to need 75 units of labor to replace 30 units of capital, which is a lot more than you will need if you're moving from D to C, which is when you have very little labor. From D to C, 5 units of labor replaces 25 units of capital. So these results makes complete sense, right? The slope of the isoquant is going to be equal to the ratio of the marginal productivity of labor. And when you have very little labor, the marginal productivity of labor is going to be high, which means the slope of the isoquant will be high in absolute terms. But when you have a lot of labor and very little capital, the marginal productivity of labor will be low, the marginal productivity of capital will be high, and your slope will be low in absolute terms. We call this, since this slope really tells you how much labor you need to replace capital, or vice versa, we call it the marginal rate of technical substitution. Very similar to the name that economists have for the utility function, right? Which is a marginal rate of substitution. Well, in here, since we are actually dealing with inputs, which saw some sort of measure of technology, we are calling it the marginal rate of technical substitution, which is the slope of the isoquant, and in any point it will tell you how much unit of one input you need to replace the other input while keeping the output the same. The marginal rate of technical substitution. Okay, in the next video I'm going to show you how to do this with a little bit of calculus.